Welcome to the digital platform for the Interoperability Center of the Municipality of PATRAS. The platform enables the municipality to have an overall view of key city operations and the corresponding data, supporting better monitoring and decision-making. On the initial screen, the user can log in as admin, employee, or guest. In this case, the employee logs into the platform using their access credentials. After logging in, the user is taken to the home page, where the overall picture of the city is presented. The user now is taken to the platform's home page. The home page acts as a central control point, where the municipality can immediately see the overall picture of the city. The information is organized into three main sections. The first section consists of key indicator cards, where the most important alerts and suggestions for possible intervention are displayed. For example, in the operational card, the system combines different data sources and scenarios. When specific values exceed predefined limits, the corresponding level of criticality is displayed, as shown here, where the situation is marked as a risk. In this way, the user does not simply see numbers, but immediately receives an indication of whether there is an issue that requires attention. Technical or operational alerts can also appear in the same cards. For example, in the Ticket Statuses card, we can see that the system was not able to retrieve data. This immediately informs the user that they should contact the technical manager so that the cause of the issue can be checked. The second section of the home page is the interactive map. Here, the municipality can see geographically the points and sensors that feed the platform with data. The points are grouped on the map, so the user has a clear view without excessive information. By clicking on a point, more information appears for that specific location, allowing the user to assess the situation more directly. Through the filters, the user can focus on specific city zones, specific sensor categories, or specific operating statuses. Next, to demonstrate the filters more practically, we select the Fire Detection category. Then, we can select the Mobility category and more specifically which parking slots are for disabled people. Then, from the Sensor Status filter, we can select the OK and No Update indicators. The OK indicator shows that the point is operating normally, while No Update helps identify points that may require technical inspection. The third section of the homepage concerns the city's key metrics. Here, aggregated data from the last hour is presented, so the user has an immediate view of the current situation. For example, the platform displays information such as average temperature, humidity, bin fill level, occupied parking spaces, and air quality. At the same time, it also presents more specific indicators, such as active fire warnings, manholes at critical level, and the average noise level in the city. Next, we move to the first thematic section of the verticals, which concerns the municipality's financial data. In the Overview tab, a consolidated view of financial activity is presented, such as daily revenue, expenses by service, certifications, and financial catalogs. In the Revenue tab, more detailed information about the municipality's collections is displayed. In the Expenses tab, expenses are presented in a way that helps better monitor the services. The In-House Certifications tab concerns the related certifications, while the Documents tab brings together information about financial documents and entries. Finally, in the Debts tab, the user can see data related to outstanding financial obligations. In this way, the section helps the municipality monitor its financial picture in a more centralized and immediate way. Next, we move to the Environment section. The logic here is similar to the home page, but the information focuses exclusively on the city's environmental conditions. In the Overview tab, the user can view key environmental indicators such as temperature, humidity, air quality, wind conditions, noise levels, and other related measurements. After reviewing the summary information, we move to the Environmental Sensor Map. Using the available filters, we first display only sensors that are operating normally and focus on a specific zone of the city. As an example, we select a fire detection and other environmental sensors and view its location and environmental monitoring information. Finally, we move to the second map, which presents specific environmental measurements such as temperature, humidity, and air conditions. This allows the user to switch between different environmental indicators and quickly understand how environmental conditions vary across different areas of the city. Next, we move to the Mobility section, which mainly concerns parking and movement within the city. In the Overview tab, the platform presents key indicators for the mobility situation. For the selected time period, the criticality appears low, showing that the overall situation does not present strong pressure. On the map, available and occupied parking spaces are displayed, giving the user an immediate geographical view of the situation. By selecting a specific parking space, more information appears for that point, such as the zone, provider, and occupancy. At the same time, the platform provides a short indication or suggestion based on the metrics of that point, so the user can quickly assess the situation. At the bottom of the page, additional metrics are shown, such as average parking duration, occupied spaces, and occupancy rate. This helps the municipality monitor parking and identify areas with higher or lower pressure. Next, in the Parking History tab, the user can see detailed parking records. The table displays information such as vehicle plate number, parking address, start time, end time, duration, and amount. Then, we move to the Predictions tab, where the prediction map helps the municipality see which areas may present higher or lower parking occupancy. In this way, the platform is not limited to recording the current situation, but also provides an estimate of how parking may evolve by area. Next, we move to the Parking Tickets section. This section presents the picture of parking tickets and helps monitor the status of fines. In the Overview tab, key alerts are displayed, such as increased pending fine payments, an increased number of unpaid tickets, and the picture of violations by street. The criticality helps the user immediately understand which issues require greater attention. The map displays the related records geographically, so the municipality can see in which areas more tickets or violations are concentrated. Filter by paid or unpaid and then see their amount. Next, we move to the Charts tab. Here, the platform presents the picture of parking tickets more collectively through key charts. The user can see, for example, the daily number of fines and the total amount corresponding to them. At the same time, the status of fines is displayed, such as which are paid, unpaid, or cancelled. There is also analysis by vehicle type and by recording source, so it is clear where the data comes from. In this way, the municipality can more easily monitor trends and the overall picture of parking violations. Next, we move to the Predictions tab. Here, the platform presents estimates for the possible development of parking tickets in the next time period. In the first section, cards with key predictions and criticality levels are displayed, so the user can quickly understand whether increased activity is expected. In the second section, the map shows geographically the areas where an increase or decrease in tickets is predicted. This information can significantly help the municipal police, as it provides an indication of where greater presence or inspection may be needed. Next, we move to the Cleaning section. Here, the platform presents the status of waste bins across the city. The map displays the points where bins exist, as well as their fill level. The user can see how many bins are at low, medium, high, or critical fill level. In this way, the municipality gets an immediate view of which points should be prioritized for collection. Next, we can use address search. By typing a specific address, the user can quickly locate the area of interest and see the status of nearby bins. Next, we move to the Dynamic Calculation tab. Here, the platform helps with better planning of the waste collection route. The user can give an instruction in plain language, such as avoiding a specific point or road segment. In this example, We will ask the system to exclude the part of the route that touches Hagia Sophia Square, due to maintenance. The platform processes this instruction and recalculates the route, avoiding that specific point. On the map, we can see that the problematic segment is skipped and an alternative route is proposed. This is especially useful for the municipality because it allows more flexible planning in cases of roadworks, road closures, or other unexpected conditions. Next, we move to the Citizen Requests section. Here, the platform gathers the requests submitted by citizens to the municipality. In the Overview tab, key alerts are displayed for request categories that show increased activity. For example, increased reports may appear for cleaning, street lighting, road surfaces, or other city services. The map displays the geographical distribution of requests, so the municipality can see which areas have more reports. At the bottom of the page, the main request categories are presented, together with the number of records and their status. Next, we move to the Charts tab. Here, the platform presents the evolution of citizen requests over time. The user can see how the number of requests changes and which periods show greater activity. At the same time, requests are analyzed by category, such as cleaning, street lighting, sidewalks, greenery, environment, and other issues. There is also analysis by zone or neighborhood, so the municipality can see where more requests are concentrated. In this way, the charts help better understand citizens' needs and support more organized management. Next, we move to the Predictions tab. The map shows by area whether an increase or decrease in citizen requests is expected. This information is useful because it helps the municipality identify which zones may require greater response capacity. This allows the municipality to better organize its services and prepare earlier for citizens' needs. Next, we move to the Notifications section. This section brings together important platform messages, so the user can quickly identify issues that require attention. First, in prediction, notifications messages generated by the system's predictions are displayed. For example, there may be an alert for increased risk in a zone or an expected increase in requests in a specific category. Next, we move to System Notifications. Here, messages related to the proper operation of the platform and the flow of data are displayed. For example, the system may notify the user that some sensors have not sent new data for a long period of time. This is important because it helps the user distinguish whether an issue concerns the city itself or a technical issue in data collection. By clicking on a notification, the user can see more details about the problem. In addition, the user can change the status of the notification, for example to indicate that the issue is in progress or has been resolved. In this way, the platform does not simply display notifications, but also helps monitor the progress of resolving each issue. Finally, we move to Operational Notifications. These notifications are directly connected to the operational card that we saw on the home page. When the system identifies a combination of data that exceeds specific limits, an operational notification is created. For example, increased bin fill levels, environmental burden, or increased activity in a specific city zone may be combined. In this way, the municipality can more quickly identify where operational pressure exists and which area needs immediate attention. In addition, operational notifications can be exported to an Excel file. The user can either download all notifications together or download one specific notification separately. These Excel files can help the municipality with internal reporting, incident documentation, and tracking the actions that were taken. In this way, the platform is not limited to simply displaying data, but turns data into useful alerts and practical support tools for the municipality.